Question 12. So for part 1 we've been asked to show this. So we're basically going to create our own simultaneous equations. So start off by substituting in V and D being these two numbers, which I've done here, which simplifies to this, and then substitute in V and D being these two numbers, which I've done here, which simplifies to this. So we have a pretty straightforward simultaneous to solve. So I've chosen to double the first one to line up our B's, and then to take away our second one from this doubled, which is in purple. So then taking them away, I get 90 equals 1800 over A, rearranging A as a 20th, and then substituting that back into 1, we get that B is 1. So A is a 20th and B is 1. A is a 20th, V is 1. B is 1, excuse me. So then we show what we need to, that V squared over 20 plus V equals D. Now for part 2, I think this was very straightforward, very generous really. Find the difference between the stopping distances for a car travelling at 65 and 70. So substitute in for the speed being 65 and you get this distance. Then secondly, substitute in for the distance being 70, the speed being 70, giving us this distance. Take this distance away from this distance, gives us a final answer of 38.75. Now for part 3, on this occasion we're being told that the distance is 50 and we need to find the speed. So substituting in 50, multiplying through by 20, and then taking 1,000 from both sides, we have this quadratic equation to solve. You could use the formula. I've chosen to solve it by completing the square, which I've done over here, giving me a speed of 23.166, rounding to 23.2 miles per hour.